Hi everyone, and welcome to our fourth Full Steam Ahead webinar. My name's Kaylin, and with me as always, I have Neve.
Hi everyone.
And in the background, we have the rest of the DreamSpace team ready to answer any questions that you have. So please do remember that you can put the webinar on pause at any point to go and grab some materials or to ask one of the team a question about the challenge that we're doing, or if you have any questions for our special guest. So keep that in mind throughout the webinar, that you can just put it on pause, ask us questions, or go and try and find some materials. We are so lucky today because we have a very, very special guest. We have Kate Delaney with us today. Hi, Kate.
Hi, how are you? How's everybody? Hope everybody's going to enjoy this great show.
Yeah, we're so lucky to have you. Thank you so much for joining us today. Do you want to tell us a little bit about yourself? Where are you from? What's your role?
So my name is Kate, as you said, and I'm from Dublin, from Artane, and I'm the founder and CEO of Make, Create, Innovate. So we design hands-on creative tech workshops for young people and adults. And Make, Create, Innovate has been going for, this is our 5th year, and it's great. And it's at the moment we're developing an online project, and it's great to be involved with you, and you're getting involved in your STEAM online project as well. And I can't wait to see what you're going to do today.
That's brilliant. So you're obviously, you love STEAM. So do you want to tell us a little bit as to why do you love STEAM? Why do you think it's so important to education? Just anything that you'd like to tell us about STEAM.
Well, I think probably most of the viewers will know what STEAM stands for. So it's science, technology, engineering, arts and maths. And for us, it's really important to combine these subjects and to come up with projects and workshops that are really engaging. And the priority for us is creativity. So it's how do we explore science and technology and engineering and maths creatively. And so for the workshops that we design and do, that's really at the forefront, and also just having a lot of fun and really enjoying working together, solving problems, and just thinking about what we're doing in kind of fun and new and innovative ways.
Yeah, that's brilliant. And as you said, the A is very important, and we like to show that off here as well, because we want people to be able to use their creativity to showcase what they can do with science, technology, engineering and maths. So thanks for that. And how did you get to be where you are now? How did you manage to be so involved with STEAM and in Make, Create, Innovate?
Well, I think really just through doing a lot of work with young people and with adults. So I've been involved as a facilitator for years and years, a long time. And I think what we used to do before is really use the screen a lot more and use software. And I think over time, I realized just the value of working with your hands and just being more creative, working with your hands, and I think working with others, and I think just developing projects that involved collaboration. And for me, that's really what Make, Create, Innovate is all about. And it's just a lot of hard work and just being really curious about technology and about creativity, and then a lot of luck as well along the way.
Yeah, no, I definitely agree with that. So for people who are watching, that they might be interested in doing this already. So they might already have that interest in creativity and STEAM and getting involved in all of our projects and your projects. So did you know when you were a child that you wanted to be really involved in this, or where did it come from?
No, I genuinely had no idea what I wanted to do as a child. And when I thought about growing up, I thought about lots of fun things, but I didn't know what career I would have. But one thing I do remember as a kid is I was really lucky to get a computer. It's something that a lot of households have automatically now, but when I was a kid, it really wasn't. So for me, getting a computer and having it break a lot is a really early childhood experience for me, and kind of learning how to get over the feeling of failure, to be honest, and just trying to continue and push on and keep trying. And that is a really strong memory that I have as a child. And I studied music in college, and that's, I think, where some of the creativity comes from. So I think it's combining the things that I love to do as a child, which is making, and I suppose maybe things not working out the way I wanted them to all the time with computers, and then adding the creative element of it too, with sound and music and art and stuff like that later on.
That's amazing, especially because you're able to do something that you love so much and have loved for so long as a job. So that's very inspiring for a lot of the children that are watching. So is there anything that you would like to tell us about? Any special projects you want our viewers to learn about?
Well, yeah, we're just starting to get into online activities ourselves, and we've started a project called MySpace. It's a 3-week project. It's starting on Monday, and it's part of Crinne na nÓg, so it's Ireland's National Day of Creativity for children and young people. And so during the 3 weeks, you'll have a chance to show the world a place that you love, and or redesign a place in the way that you'd like to see for the future. And you'll use 3D modeling, circuitry and sound to make this more interactive. So it's a great way to explore STEAM subjects, and it's going to be lots of fun. And at the end of it, you'll have a 3D model. And just to let you know that you will be using materials that you've got at home, but you will also be sent kits as well. So you'll be able to work with basic electronics kits to work with LEDs and circuitry and that kind of thing.
That's really exciting, and we'll be given a little bit more information later on about how people can get involved as well for that project. It sounds really exciting. I'm very jealous that I can't participate in it because it sounds so exciting. Do you want to tell us one fun fact before we get started on our challenge? A fun fact about yourself?
Well, something that I really like to do when I'm really very thirsty is drink pickle juice from the jar. I don't know if anybody else is into that. I think a lot of people don't like it, but maybe someone watching will also like to do that too.
I think that's definitely an interesting fact about yourself. So thank you so much, Kate, for that. If anyone has any questions that they would like to ask Kate, please put them into the Q&A section, and we'll get back to them as soon as we can. So thank you, Kate. Okay, so let's get started thinking about today's challenge. So our themes for today is science and art. So we were talking there with Kate about how creativity is so important. And for this challenge, it is definitely going to be important because we want you to put your own creative flair on what we're doing today. We're also going to be doing a science experiment. So how could we use science to create something and build something? Okay, and we're also working with float or sink. So that is the name of our challenge today, is float or sink. So when we think about that, we can think of water density, maybe, and the different items that float in your bath or float when you go to the swimming pool. So we're going to learn a little bit more about water density and how this can contribute to our creative science experiment. So today, we are going to be making our very own lava lamps. So I know that when I was younger, I adored my lava lamp. So we're going to be learning how we can do that today through science. But for now, I'm going to pass you on over to Niamh, who is going to very quickly talk through the materials that you need and how you can get them and how you can find them for next week and following webinars.
Thanks, Kaylin. Okay, so as usual, we've uploaded the materials recommended for today's webinar on our Wakelet. So again, you just go to the DreamSpace HomeSpace Wakelet, and then on the main Wakelet, go down and find the Full Steam Ahead series. Okay, and once you click into the Full Steam Ahead series, there'll be a number of PDF files in there. Okay, and in the PDF files, you're going to have to look for the number 4. Okay, to distinguish this week's webinar, because this is our 4th STEAM webinar. How the weeks are flying by. So the materials recommended will be in that PDF with the number 4. So if you click into it, you'll be able to see all the materials we recommend for this webinar. Okay, and don't worry, as I've said previously, if you don't have all of the materials, you can improvise, you can get creative and come up with another way to complete the challenge. So don't worry if you don't have all of the materials. So now I'm going to quickly go through the materials that we recommend for today. So as usual, we have our 4 different sections, and this is for the build section of the lava lamp. Okay, so how we're going to build our lava lamp. So we would advise that you pick one item from each of the 4 sections, from the blue, yellow, green and pink section. And again, as usual, I would just say maybe ask a parent or guardian's permission before you're using the scissors, or maybe if you need some help, ask them for some help, okay? Because we don't want any accidents happening. Again, today we have a second set of materials that are going to be important because they're going to enable us to actually complete the experiment and get the lava to move up and down the lamp. So there's no point in just building it, and we want to be able to do the experiment part of it as well. So that's okay. And in this set of materials, we would recommend that you pick one item from the blue and the yellow section, and you will probably require both items from the green section, okay, in order for the experiment to be conducted. So don't worry if you don't have them today. You can do your build and then you can access the materials such as the vegetable oil at a later date and complete the experiment. So today we're going to be building a lava lamp, but what do we actually need to know before doing that? Well, we need to understand a little bit about water density, okay? And water density describes the space that an object or a substance takes up. So it's volume in relation to the amount of matter that it has in it, so that that object or substance has in it, so it's mass. And lower density solids or liquids will float, whereas something more dense will sink, okay? So something with a higher density generally sinks. And measuring density is useful to us because it allows us to differentiate between materials, because substances have varying densities. So it allows us to know what materials what, okay? And a common kind of thing we think about, or a common example of this, would be a ton of feathers versus a ton of bricks. So a ton of feathers and a ton of bricks both weigh the same because they're both a ton, but a ton of feathers will occupy a much larger volume or its density than a ton of bricks. So density, where did it all come from? The story of density, or the origin of the story, is actually quite a famous one in the world of science. So the Greek mathematician, physicist, and astronomer Archimedes, he was the person that first discovered that there was actually a link between volume and mass. And you know how he discovered it? While relaxing in his own bath. I never get any moments of epiphany when I'm in the bath like that. Okay, so how he discovered it, or as the story goes, he got into his bath and the water spilt over the sides. So he thought about it, and he was trying to solve a problem already because he had suspicions that someone was replacing the gold in the king's crown with some silver. So in order to prove this, he got 2 tubs of water, the exact same, and he placed the actual crown in question that he thought someone was tampering with into one of the tubs, and then he placed another crown that was pure gold of the exact same mass as the crown was meant to be into the other tub. And what he noticed was more water flew over the sides of the one that was the actual gold one that he had got made up to check the original one than the actual original one. So not as much water flew out of the sides of the original one that he thought someone was tampering with, which proved that someone actually was tampering with it, because by right, both of them should have had the same amount of water flying over the sides. Okay, so that proved that there was a different material as part of the original crown, which was the silver, that's a fraud had been tampering with and changed. And it meant that obviously silver and gold had different densities, so one weighed more than the other. Okay, so that's a fun fact of today. So I'm going to pass you now over to Kaylin, and Kaylin's going to get started on our build for today's webinar.
Thanks, Niamh. And that was a really interesting stories about Archimedes. I always find it really interesting how you can have that epiphany moment at any time. So you could all be scientists at home and you're just waiting for your eureka moment to happen. So we spoke a little bit there about water density and about how lighter density items will float on top of heavier density items. Okay, so let's think about our challenge today. We're talking about floating or sinking, which is with density. So let's test out a few things before we get started on our challenge. So I'm going to give you a few different items that you might be able to find around your house. And I want you to either guess, or if you have the items, test it out and see if these items float or sink. I then want you to put the webinar on pause and let us know in the Q&A section Why does it float or sink? Why do you think these items float, or why do you think they sink? Okay, so the first item that we have here is a pencil. So a wooden pencil. Do you think it will float to the top of the water, or do you think it will sink? The next one we have is marbles, or little ball bearings. Okay, so a little marble. We're going to think of the glass marbles. Okay, then we have a glass bottle, so an empty glass bottle, and that's important, it's empty. We have a football. So this is one of our bigger items. It's a big football. Do you think it will float, or do you think it'll sink? We have a little golf ball as well. If you think of a little golf ball, what do you think? And then a stone or a pebble or a rock. Okay, so if you want to put the webinar on pause now, go and test them out, or just guess yourself and say why you think they would float or why you think they would sink, and put it into the Q&A section before we give you the answers. Okay? Right, so the very first one, our pencil. Our pencil will actually float. Okay, so if you got that one right, good job. The next one is our marble. So our marbles, which are made of glass, will sink to the bottom, which you might have thought of because they're quite heavy and they're a nice little item. They might fall to the bottom. The next one is our glass bottle, our empty glass bottle. Okay, so it'll actually float, even though it's made from the same material as the marbles. And it would actually be quite bigger than the marbles. The marbles are only small. The bottle would be a lot bigger. Okay, so we'll talk about that one in a second. Then we have our golf ball. So our golf ball would sink. Okay, I might have thought that one because I think a golf ball is heavy for the size that it is. Okay, so it sinks. Then we have our football. So, okay, so it floats as well, but it's also a big item. So from what we're seeing here, our two biggest items are actually floating, when you would think, or I would have thought first, that they would sink to the bottom. And our last one is our stone. Okay, and our stone would sink. Okay. Right, so let's talk about the two really interesting ones there. So our glass bottle and our football. Okay, so why do we think our glass bottle would float if we put it into a tub of water? Well, the reason is because when we're talking about density, air is actually less dense than water, which means that the air is trying to get up to the top and it will try and float. So if you have an empty bottle, it's not completely empty. There's still air inside of it. So the air is what's pushing it up and it will float on top, no matter how heavy that bottle is. Okay? Whereas if you wanted that bottle to sink, if you wanted to make it able to go to the bottle, what you could do is remove all of the air from that bottle. And you can do that by filling it up with water. So if you had your bottle, you took the lid off, put it in sideways, it will fill up with water and then it will sink to the bottom. So that's a really interesting little experiment that you can do as well at home and test out and see, when does your bottle float or when does it sink? The next one was that football, okay, which was a big object in comparison to the other ones. And we said that it would float. Okay, so if you cut a football in half, is it completely solid the whole way through, or what's inside of it? So when you cut it in half, you'd actually pop your football because there's air trapped inside. So the same goes for the football as for the bottle. Because there is air trapped inside of this football, it is forcing it up to the top of the water and forcing it to sit on top and to float. But over time, depending on your football, it might absorb the water. It might suck all the water inside of it. And that means that there will be less air inside and it could start to sink. Okay, so if anyone has had a football that they left outside in the rain, or if they left it in a swimming pool and it slowly started to sink, that was what was happening because the air was leaving it and that space was being filled up with water. So that's all really, really interesting. And at home, if you want to test out some more materials and why you think it'll float or why you think it'll sink, do those experiments at home yourself and guess beforehand and then test out your experiment. Okay, so let's try and use what we've learned to get started on our challenge. So our challenge today is something I'm very, very excited about. So we have to make our very own lava lamp, which is something I think I've dreamed of doing since I was a child as well. So we're making our own lava lamp using the materials that we have available for us at home. We're then also going to build a stand so that it's not just a boring lava lamp on its own. We're going to be really creative with it because, like Kate said earlier on, we want to try and promote that creativity in everyone. So you're able to be as creative as you can in all of our challenges. So you're going to build a stand or a type of backdrop for your lava lamp, and then we're going to try and light it up. Okay, so we can see how we're going to do that in a bit. But let's just think about a few things before we get started. So how can we use this equipment to create a stand? Okay, so what do we need to take into consideration before we build this stand? Okay, so we need to think about the weight of our materials and the weight of our lava lamp. So what exactly could we use that would make our lava lamp stay in place and not move around in its stand? Or what could we add to our stand to make sure that it's sturdy, that it is strong, and it doesn't cause our lava lamp to fall over or crack inside of it? Okay, so there's a few things that you can think about there. What weight are the materials provided? So that links with that first one. So how heavy is your lava lamp going to be in this stand? And do you need other things there to support it? How could it affect it? What do you think? And our last one there, which I might get Kate actually to jump in on, is can we light our lava lamp up? And how do we think we could do this? So Kate, do you want to tell us a little bit about what you think we should do, or maybe something that you would do? I think you're on mute there, Kate.
Thanks. I think you can really do some really interesting things with light. Some of you will have heard of LEDs, and some of you will have maybe used them in school. But they're great ways to light up things, and so you see them in lots of things around the home. And so I've got one here, just with a battery, and you can light it up and then use it to maybe shine some light under your piece or over your piece or somewhere else in your piece that you think might work well. So it's just a simple little LED that you can light with a 3-volt battery.
Okay, that sounds absolutely perfect for our lava lamp. And because you can get LEDs in so many different colors, we could also make it really colorful. So thanks, Kate. That was brilliant. So LEDs are really, really cool, especially in our challenges. That if you can add them in to make it more creative and more colorful, please do. Okay, so we're going to start our challenge now. And please remember to be as creative as you want with your build. Okay, so let's get started. So the first thing that we are going to do today is we are going to build a stand for our lava lamp. So we have our bottle that we're going to use for our lamp. We've an old shoebox with some more cardboard inside. We've our paints and some paintbrushes. I also have an old ice tray here, which I'm going to use as my paint tray. So if you wanted to do something like that, you could as well. I have some scissors, some blue tack, tape and glue, and then a marker and a ruler as well to see if I want to measure anything out, but they're not really necessary. Okay, so let's have a look at our bottle first and see what exactly can we do with our materials to create something that'll make it stand up. So in our experiment, we're going to have all of the materials down at the bottom. So it's going to be standing up straight like this. So let's have a look at our shoebox. Okay, so we have our shoebox here, and we have some other pieces of cardboard inside. So for the moment, I'm going to just take them out. And we want to be able to create a stand that we can close over and put away nice and neatly so that it's not taking up any space, or we can turn off our lava lamp if we want to. So I think we're going to keep the lid on for our stand here today. And then let's see if we can get our bottle to fit in. Okay, so we can see that it's just a little bit too big for our bottle. Okay, so let's use our critical thinking skills here. What could we do to try and help our bottle to fit inside of our stand here? Well, we could use another piece of cardboard as a little stand at the bottom. Okay, so let's put that to the side and keep that in our heads for now. The other thing that we could do is create a little hole at the top so that our bottle is hanging almost inside of our stand. And that would mean as well that you could put something underneath it down here. Okay, so let's have a look at that. So I'm going to look at the top of our box here. I'm going to pull open this. Okay, and now let's look at the top. So I can see that there's a little hole here. Now let's see if we can use the hole that's already there instead of having to cut out a new one. Okay, so our bottle's still kind of falling out there, but if we put a little bit of tape to hold this piece of cardboard with this piece of cardboard, then our bottle is almost hanging there in our stand. Okay, so let's cut this piece of cardboard off and put a little bit of tape here to see if that will work. Okay, so let's test that out now and see if our bottle will stay when we put it in up here. Okay, and it seems to hang there perfectly. We also want to be able to take our bottle out and refill it if needs be. So by having it like that, it means that it's nice and secure there, but we can also take it out and refill it. Okay. Now let's think about making it even more stable when it's inside so that it's not swaying all over the place. Okay, I'm going to use the idea that we had earlier on of putting a little stand at the bottom. So the first thing I'm going to do is I am going to cut this cardboard so it is the same size as the bottom down here. Okay, so now we have this piece of cardboard. Okay, so we want to create something that can help our bottle to stand up. So if we bend the sides here, we might almost be able to make a table type structure. Okay, and then it'll be pushing against the sides here. So let's test that out. Okay, so I've bent the two sides in there. It doesn't matter if they're even, but I tried my best to make them even. And now I'm going to try and see if they will fit inside here and if I need to cut off any of the bottom here to make our table lower so our bottle can still fit in nicely at the top. Okay, so it seems to fit in, but it seems a bit too tall. So I'm just going to trim off bits at the bottom until I can get it to fit so that it nicely sits underneath the bottle up here. Okay, so that seems to work because we have our bottle standing there and now it's also attached to the bottom. Now I want to create a little hole in our stand here to let in our light. Now, again, if it's not a perfect circle, that's okay. I just wanted to cut it out in a circle there so that I could put something underneath it and it could shine up. Now I'm just going to tape this little line closed here. We can see that our bottle is kind of sitting at an angle there. So what I might do is try and see if I can make this hole here a little bit bigger. And if it doesn't work, that's okay, but let's test it out and see if it does. Okay, so that seems to be sitting a little bit better, but I can try and cut out a little bit more of this cardboard up here if I wanted it to be even more straight. So now that we've all of that done, let's paint our box and try and design a cool background for our lava lamp. So today I'm going to be going with a galaxy theme or a space theme. So I'm going to try and paint the entire of the inside here black. Then I'm going to use our little stand as almost the moon. So I'm going to try and paint it white. And then I'm going to put little specks of blue, white and purple in there as well to decorate it and give it a nice galaxy theme. Okay, and when our box is drying, we're going to paint our moon or our star in space white. I'm also going to add a little bit of yellow to this as well to make it look more like a star, but only a very small bit. Okay, and while that one is drying, let's go back over to our box and add in some of those colors that I mentioned at the beginning. So I have some more white that I'm going to do little stars, and then I have some blues and purples that I'm going to add little splashes of decoration as well. Okay, so now that that is drying, we can stick in our little stand. If your stand has gotten a little bit weak because of the paint, what you can do is stick another piece of cardboard here to keep it flat. And that is our stand for our lava lamp. We'll be able to put our lava lamp in like this. Okay, so now that we have our stand built, let's get started on our experiment. So our experiment is going to test the water density against oil density. Okay, and in doing so, we're going to create something really, really cool. So my materials, I have some oil, I have some water in a jug, I have food coloring, a funnel, my bottle, my stand, and I have some glitter. So you don't need to use a funnel. You can also use a piece of plastic if you have that, or you can just try and neatly pour the materials into the bottle yourself. You also don't need any glitter. I just wanted to add some bit of a flourish to my lava lamp to make it look even more interesting. Okay, so the first thing that we have to do is put some water into our bottle. So now we have water in our bottle. The next thing that we need to do is put in our oil. So now we're going to be able to test and see, will the oil float on top or will it sink to the bottom? So we can see now that the oil is actually sitting on top of the water. So what does that mean? Okay, I'm going to shake off my funnel. Okay, and now I'm going to let my oil sit. So you can see now that there are little bubbles in my oil, and that is just from the oil and the water is trying to separate, and they're air bubbles that got trapped when I was pouring it in. So I'm going to let that settle for a few minutes. So our oil has settled a little bit there. The next thing that we are going to do is we're going to add in our color. I think I'm going to use the red. because I think it might show up the colors well. Okay, so we can see there that there are already some bubbles in our oil. You can see that there's already some bubbles of food coloring there in our oil. The next step is to add our Alka-Seltzer. Now the Alka-Seltzer, when it reacts with the water, it is going to create air bubbles. So the air bubbles will then try and escape by creating bubbles in the oil and trying to push up out of the bottle. So let's add in one of these tablets and turn on our lava lamp. While that is bubbling away, I am going to open up my lid and I'm going to add in some glitter. And I'm going to put in another tablet of Alka-Seltzer, and this time I'm going to put it in our stand as well and see what it looks like. So we can see that cool reaction going on there. Let's see what happens if we add a light underneath our lava lamp to see if that would make it light up like a real lava lamp. So we can see there that it's lighting up our lava lamp and making it look really, really cool. Okay, so that was our lava lamp. So I want everyone at home to be as creative as you want with your lava lamp. I want you to create a different background. I don't want you to do the galaxy one that I did with all of my blues and purples. I want you to try and come up with something even better, okay, something more creative. So what happened in our experiment there? What was the reaction? Well, we had our water sitting at the very, very bottom. Okay, so we have our water at the bottom, and then we had our oil sitting on top. So then, like we just said, we put in our Alka-Seltzer, and that, when it mixed with the water, it started creating air that needed to be pushed up because our air is less dense than our water, which means that it should float or go to the top. We also learned that our oil is obviously less dense than our water because it is sitting on top of our water there. And what I've done is I let mine sit for a little bit, and I know that if I were to put in another tablet now to activate my lava lamp, that it would look even cooler, because I don't know if you can see, you kind of can, that there's a line of glitter here. So the glitter is actually sitting in between the water and the oil. It hasn't mixed with either of them. It's sitting in between them. So what do you think that means? So I want you to pause it now and put it into the webinar. Sorry, put it into the Q&A section and say, why do you think the glitter is sitting in between? So obviously it's less dense than one of those materials and more dense than another, but which one? Okay, so I want you to put that into the Q&A section there and have a little think about it for a section as to why does the glitter sit in between both of them? Okay, so we had a lot of fun there with our challenge. I know I definitely did. But I'm going to pass you on over to Niamh now, who has been keeping an eye on our questions to see if we've any questions for Kate.
Thanks, Kaylin. Okie doke, so we've lots and lots of questions, Kate, so I hope you're ready. Loads of people interested in how you got interested in STEM and loads of different things. So I'm going to start off with the first one. How did you think the challenge went, or was there anything you noticed or anything you would have done differently?
I think the challenge was great. It's a great way to explore just working and learning about science in a hands-on way. And I think adding the piece, the background piece, and a place for it to sit, I think works really well too. So it'd be great to see if anybody can work a little bit more with LEDs and batteries and make their own lighting source themselves. But I think as an overall project, I think it's really fun and really interesting and a great way to learn about density.
Great. Thanks, Kate. Another question we have here is, did someone inspire you to go towards the STEM area, or was there a role model that maybe had previously worked in this area that you thought like or got inspiration from?
I'm not sure. I think education was something that I was really interested in, and technology and being creative. And so I don't know that I knew anybody that was doing all of those things, but they were the things that I really loved, and I really wanted to bring them together and I suppose working with other people. But I come from a family of musicians, so I think the kind of the music side and working with sound and creativity was something that I grew up with, and artists on my mum's side. So I think that creative element was always there. But I think for me, I really enjoy seeing other people's creativity, and that's the bit where the kind of teaching part comes. I love just to observe other people working creatively and trying to encourage them to do that. So it's being part of the process with other people that I like a lot.
Very good. Sounds good. And another one that actually leads from that question, sorry, is there a particular area of STEM or STEAM that you prefer? So is there any of the areas that you would prefer more than the other areas, or that you would have more of an interest in?
In terms of the subject? Yeah,
in terms of the subject areas.
To be honest with you, no. I mean, I really like them all. I suppose I think some are a little bit easier to develop workshops around, and some are a little bit trickier. But I just see that as a challenge, because I think that schools are now starting to see that working with your hands and being creative and exploring science, technology, engineering, arts, and maths. It's exploring them in a hands-on way, kind of through experimentation, as you've just demonstrated in your challenge, I think is a really great way to learn. So for me, no, I really like all of them. I mean, I think science generally I really enjoy, but I really like them all, I think, equally.
Yeah, like they're nothing in terms of them being integrated together. That's the whole point of STEAM. They don't stand alone in terms of STEAM. They're all incorporated together.
Exactly.
So I totally understand where you're coming from. Another question we have here is, did you study any particular course that led you to your career path that you're in at the moment in college, or how did you get to where you are? I know we had this earlier, but it's more so in terms of college courses, I think this question is coming from.
Well, there is no college course. Well, there is now, I think, very recently in STEAM, but so the thing about it is, I think, and that's maybe the problem, is that we don't teach subjects together in that way. We separate them. And I think it's when we can try and explore them together, then things can get really interesting, when scientists talk to artists and artists talk to engineers and engineers talk to mathematicians. But from a study point of view, I studied classical music and music technology. So that's probably where the technology kind of helped on the music side. And then after that, I just really liked working with film and video and animation. So I think it's really just exploring things in my own way and teaching that. But the electronics part, like working with LEDs and soldering, that is something that's quite new, I think, for a lot of people, that kind of maker culture. And so it's really combining that really started Make, Create, Innovate. So there wasn't any job that combined all of these things, and there still aren't that many. So it was really a case of really trying to think of something different and think of the things that I loved and trying to make it out of that. I mean, that's what a lot of people are doing now. It's being an entrepreneur. It's how can I think of things that I think are needed, maybe in the world or maybe in education, and how can I make something that fits well.
Great. We've another question here asking, what has been the best project that you've been involved with or you've made, and what's been the hardest project? So that's probably going to be a tough one to narrow down.
I think any project that involves fun and making, I think I really enjoy. But it's funny, this year we're working on Crinny the Nogue, but last year we did a big project for Crinny the Nogue where we designed these huge pieces. It was based on climate change. And I was working with young people in Blanchardstown, and they designed these massive pieces made out of cardboard and spray paint, and we worked for weeks and weeks and weeks. And it was basically interactive, so it was to show people and teach people about climate change, but and we used makey technology to make the sound work. And it was a massive project, and we worked with a couple of different people on it. And I think 2,000 people visited the space that day. It was out in Swords Castle, and that was definitely a massive challenge because we had to do the project in such a short space of time. But the young people that we worked with were absolutely brilliant, and it was all of their ideas that around climate change and some of the stuff that they've done in school, and they were able to then make these pieces and then record the sound and then make them interactive. So that was probably the most recent kind of very, very challenging and very rewarding project that we worked on.
That sounds incredible, Kate. And I'm going to leave it with one last question. I know there are some other questions in terms of the Make, Create, Innovate, which you will be coming to now in a second. So I'm sure you'll cover it. And if not, I'll ask you those questions. But the question that I'm going to leave on, which I think is actually a really, really good question, is where do you find your inspiration from? Do you find it hard to come up with new ideas?
I think it's inspiring just seeing how other people work. And I think for Make, Create, Innovate, we work a lot with artists, and they are, by profession, very creative people. And I think it's just collaboration. The inspiration comes from collaboration. And then I suppose new technology comes along, and then you think about different ways to make it work differently. So I think seeing how artists work and seeing what other projects are happening around the world, I think can really, really inspire, and just taking little bits and pieces from those and then adapting those to make them work better for you and for your group setting. So I think inspiration everywhere, from nature, from technology, from science, and from artists, and from working with young people and adults that come up with ideas all the time. And it's really, when you're working with other people, I'm always really just amazed by how, because they have to come up with the ideas, and they are the ones that are making the pieces in the end. And so to see how their brains work, and everybody's got their own way to be creative, and I think that's really inspiring, probably the most inspiring thing out of everything.
Thanks so much, Kate. Thank you. So we're going to just leave our question and answers for Kate there for a moment. She will be coming back on to explain all about her Make, Create, Innovate project now in 1 second. But we're going to move on to what we actually covered today in today's webinar. Okay, so we covered lots of different things. We covered facts about density, floating and sinking. And we discovered some items float and some items sink. So for example, in water, our pencil will float and our marble will sink. Okay, and if you want and you've extra time, I would maybe suggest testing out some other items, maybe guessing if you think they're going to float or sink them, why so, and then testing them out if you've some extra time over the week before next week's webinar. We also learned how to build our own lava lamp, and we learned how to construct a stand for our lava lamp. Now, one thing I would like to just say, we've got a few questions in our Q&A section, saying people wanted to build their an underwater lamp and stuff. Excellent, but just think outside the box. Obviously, don't be mixing water with electricity. We don't want any accidents or any hospital visits. So think outside of the box, maybe for items that might glow, or just think of other ways you could create that. And also, some people were saying that they might try the experiment like Alchemides in the bath. Maybe leave it to outside and have a parent or guardian supervising, because you don't want to flood no bathrooms. Okay, so I'm going to move on now to our home challenge for this week. So this week's home challenge is to plan and create your own lava lamp. So that's the first part. Okay, and test it out. The next part is to see if temperature affects our lava lamp. So we would maybe recommend testing out making more than one lava lamp, maybe 2 or 3. So a rainbow of lava lamps using different food coloring if you want. And to do this, you will need to use different temperatures of water when you're making the lava lamp. So maybe get a parent or guardian to supervise and create one with hot water, then create another with maybe lukewarm water, and then lastly create one with cold water, and see if the temperature affects the experiment. Does it make any difference to the bubbles, or will it make any difference to how the lava lamp actually works? Will it work the same? Okay, and finally, the last part of this week's home challenge is to get creative. And as I said earlier, think outside of the box for things that you could add to enhance your lava lamp, to make it more unique and like more personal to you, so that it's different to everyone else's. So maybe if you sequins or different things lying around the house, just like Kaylin enhanced hers with glitter, see if you can think of any other items that you could put into your lava lamp that would enhance it further. Okay, so now I'm going to have a quick look at the generic Q&A section and see if anything else popped up there. Okay.
Before we do that, Niamh, we might just hand over to Kate to explain her My Place project.
Apologies, sorry, Kate.
No worries. So I talked a little bit about it at the beginning, and just to give you a little bit more information, it is a 3-week project, and it explores building and making and interactivity, and it's part of Cruinniú na Nóg this year. So you can join on your own, or you can work in teams in your family, and you'll be using materials that you find around your home, but as well we'll be sending out electronics kits so that they can add circuitry to their pieces. So basically what you're making is 3D pieces and 3D models, and it's about showing the world a place that you love, and or redesigning a place in the way that you would like it to be in the future. And so using 3D modeling and circuitry, and then sound design as well. So if you'd like to join us, it starts on May 18th, and we'll be putting out videos and webinars weekly to help you through the process.
Thanks so much, Kate. That sounds really exciting. So Niamh, now if you want to go through the questions that you saw in the Q&A section.
Great, yeah, so there's loads of questions there. I've picked out 2. The first one I'm going to direct to Kaylin. Kaylin, is the lava lamps that we buy in a regular electrical shop made the same way, or are they made using the lava from a volcano?
Well, I think if they were the lava from the volcano, the glass would probably shatter, but that's a really, really good question. They're actually made with a similar mixture. So they do use a liquid and then oil to create that effect, but they also add in wax. So they add wax to the oil, similar to like candle wax almost. And that helps that the balls and blobs that you saw created in the oil, it helps them hold together and keep shape even more so in the water. And then also our lava lamps usually use a little bit of heat. So when your lava lamp is turned off, like a real lava lamp, when it's turned off, it's not doing anything. And then when you turn it on, the wax and the oil start mixing around. So the wax actually stays solid when it's cold and then heats up when that light is turned on to help those blobs create and take shape. So that was actually a really interesting point that I saw there in the Q&A as well, is that people were talking about how they could add different lights, and just be careful with that, because some lights do create heat. So be careful that you don't add some plastic to your lava lamp and create a hole in the bottom of your bottle. But yeah, a similar mixture.
And I see another one here, Kaylin, and it's, can you build the lava lamp without building the stand? Because I have no cardboard box. So obviously this person participating in the webinar today doesn't have any cardboard box. So can they just build the lava lamp without the stand?
Yeah, of course you can. You can, of course. That means that you just have the bottle there. But if you don't have a cardboard box at home, just be creative with it. So you could simply have it in front of a wall that is a particular color, and blue tack little pieces of creatures, or I saw one with an underwater theme. If you had a wall in your house that's blue, you could stick on little fish to the wall, and that could be your backdrop instead of having a stand. So of course you can. Of course you can.
Great. I think that's all the questions for now, Kaylin. So
thank you, Niamh. Okay, so I just want to say a huge thank you to everyone for joining in with us today. I hope you all had great fun with your lava lamp experiment. I also want to say, obviously, a huge thank you to Kate. So thank you so much for joining us, Kate. Hopefully
thanks for having me on.
We were very lucky to get you, because you were very busy, obviously, with your My Place project. So thank you so much. It did mean a lot, and we learned a lot about creativity from you. So thank you so much. Very quickly, I want to say that if you want to share your towers from week 1 that you would have created in our very first episode, you can now do so. So there's a great opportunity for you to be able to share your towers on the Facebook page for the UCD Festival or on the festival.ucd.ie webpage. So that page is going to go live from tomorrow, and you'll be able to see all of the information on how you can share your towers to be part of that festival in UCD. So register your interest there on that webpage on your screen now to register your interest, and then learn more about it tomorrow once the webpage goes live. Okay, so thanks again for everyone for joining. We want to say another thank you to Engineers Ireland for supporting the webinar throughout. And do remember that you can check the resources that you need and the materials that you need on the Wednesday before our webinars begin, and you can check out all of our on-demand lessons and everything else that you want in regards to our webinars on our Wakelet, which is on your screen now. So thank you so much for joining, and we'll see you next week.
Thanks everyone. Have fun in creating your own lava lamps.